Hello everyone, welcome to our video solution to problem 2 from Superquiz 1. In this problem, we're given a differential equation. Whew, what a monster. I notice if this had been a 0 instead of a t squared ln of t, this would be a Cauchy-Euler equation. Cool. The good thing is we don't have to solve this differential equation because a general solution is given down below. So we already know this has general solution, this thing. Now this A and the B, right, this is how we know it's a general solution because these A's and B's, right, might be any constants. So if we want to actually determine a particular solution, right, we're going to need some initial conditions. And hey, right on cue, we're given that y of 1 is equal to 0 and that y prime of e is equal to 23 over 6 times e. Oh my goodness. Okay, and then we're asked to find the corresponding particular solution. Okay, well, why don't we use these two data points, right, to help us find our A and our B. So first thing, we know that 0 is equal to y of 1. Okay, well, what is y of 1? Well, y of t, for any t, is given by, right, this expression. So if I want y of 1, I just make t equal to 1. So let's see, we get a times t squared, so that's just going to be a, plus b times, okay, t squared, that's just a 1 now, and then ln of 1. Ooh, what is ln of 1? Let's see, that's the number I have to raise e to get 1. Oh, you have to raise it to the 0th power. Cool, so this is actually a 0 in that case, so this whole sum n goes away. And oh, wow, this is amazing. For the exact same reason, right? ln of 1 over here is 0, so this whole sum goes away. So in fact, this whole expression just becomes 0 equals a. Hey! So in our particular solution, there is no t squared term. Fantastic. Okay, but we still have this b. And what have we been told? We have something about the derivative of y. Oh, we don't have the derivative of y. Well, I guess we should take the derivative of y. So let's see here. Now, I'm going to write it down just because it's faster just to write it than to get rid of it. But we already know a is 0, right? So that's just going to be a 0. Okay, plus, now I'm taking a derivative. B is a constant, so I can keep that there. But now I have a product. So I'm going to have to use the product rule. So let's see here. We'll do t squared times the derivative of ln of t, which is 1 over t, plus, now I take the derivative of t squared, which is 2t, times the natural log of t. Okay, and this bit I can see quickly, t squared over t, as long as t is not 0, which, hey, t is not 0, that'll reduce to t. Excellent. Now I need to do this bit, plus, okay, I have a 1/6, and again, yeah, we're going to have to use a product rule, and ooh, it looks like even a chain rule's coming. So let's see. I have t squared, and then I need to multiply by the derivative of the cube of ln of t. All right, so chain rule's coming, so I do 3 times the log of t squared. Okay, so 3 times the log of t squared times the derivative of log of t, right? That's the chain rule. So the derivative of log of t is 1 over t. Oh, we got to do the other half now, right? Okay, because it's product rule. So plus, now I take the derivative of t squared, which is 2t, times the natural log of t quantity cubed. Okay, so that's the derivative of y. And the data point we have is when t is equal to e. So we get 23 over 6 times e equals y prime of e. All right, so what is y prime of e? Well, okay, again, we knew this first term was 0 anyway because a was 0. Then we have b. Okay, here's my t, and that just becomes e, plus, all right, we're going to have 2e, and then I have the natural log of e. Natural log of e. That's what I have to raise e to get e. Oh, you have to raise e to 1 to get e. Okay, so this is just 1. Oh, that's great. That's going to be a 1. So I just get a 2e. Hey, this is just going to be a 3e. Okay, next I have 1 over 6. I'm going to have e squared. times, okay, well, we already know the ln of e is 1. So this is just 3 times 1 squared. Oh, I forgot. Here, look, we have t squared over t. Oh, that's even better, right? We're going to be able to get rid of an e because we could simplify, right? This is 3t ln of t squared, right? T squared over t is just t. Okay, so now it's actually 3 times e, and then this is a 1, plus, okay, now I have 2 times e, and again, ln of e is 1, so I don't get anything else. All right, so that's 5e. So in total, I have, let's see, 3 times be, and then I have 5 times a sixth e, so plus 5 sixth e. Okay, and I'm just solving for b now. Let's see, if I subtract 5 sixth e from both sides, so I'm going to subtract 5 over 6e. On the left-hand side, I'll get 18 over 6, right? 23 minus 5 is 18. 18 over 6 is 3. So I get 3e equals 3 times be. Oh, hey, I'll just divide by 3e, and that'll give me b is equal to 1. Okay, so I've discovered the values for both a and b. They're 0 and 1. And so now I can go back up here and take a peek at our general solution. And so now our particular solution is going to be y of t equals, all right, a was 0, so that term goes away. B is 1, so I end up with t squared, ln of t. And then there's no a or b in this last sum n, so I just copy it. And there we go. We have found a particular solution to our differential equation given a general solution and given some initial values. All right, we'll see you next time.